Good afternoon, everyone. Welcome to the 10th week of discussion session of the course Plates and Cells offered by NPTEL. Course instructor of this course is Professor Sudik Talukdar, and I am your teaching assistant. Myself, Asif Raza. I am a PhD scholar from Department of Civil Engineering, ISC Bangalore. So today we'll be discussing questions relevant to assignment 8 and 9. So without further delay, let's start. Yeah, so the first question is the cell construction is preferred for first option is less material consumption, second is large column free space can be covered, aesthetic sense, and the third option is all of this. Fourth option is all of this, and the correct answer is all of this. So, next question. Write true or false against the following statement. A, a conical cell belongs to a group of ruled surface. Is it true or false? Yeah, it's true. Third question. When a membrane of any arbitrary shape is subjected to transverse load Q, then the deflection of the stress membrane Z equal to Fxy under uniform tension T can be found as. So, as you have seen in the module 8, it's given by del square Z equal to minus Q by T, that is del square Z by del x square plus del square Z upon del y square equal to minus Q by T. So correct answer would be option A. Let's move on to the next question. Fourth question. A cell generated by a straight line moving over a curve such that straight lines are not perpendicular to the plane of the curve is known as. So okay, so this is quite easy. If the straight lines had been perpendicular, we could have directly said cycloidal cylindrical cell, but as it is not perpendicular, so correct answer is option C, conoid. Now next question. The elementary arc length of a cell surface can be calculated using fundamental magnitude of the surface EF and G as this. If the surface of cell is defined by this, then at point on the surface the value of E is. So to solve this, we are given with z equal to 0.2 x square plus xy plus 0.3 y square, right? So del z, let's find del z by del x, and it is equal to 0.4 x plus y, right? And del z by del y equal to x plus 0.6 y. Okay, to find E, just we use this formula del z by del x square, and this is equal to 1 plus 0.4 x plus y whole square. At 1 comma 0, E is 1 plus 0.4 into 1 plus 0 whole square. This is 1 plus 0.4 square. This is 1.16. So E is 1.16. Now let's find the other F and G values also. Let's try to find those. So G is given by 1 plus del Z upon del Y whole square, and this is equal to 1 plus x plus 0.6 y whole square. At 1 comma 0, G would be G equal to 1 plus, this is 1 plus 0, so this would be equal to 1, 1 plus 1, 1 plus 1, that is equal to 2. And similarly F is given by del z by del x times del z by del y, which is equal to 0.4 x plus y times x plus 0.6y at 1 comma 0 f is equal to this is 0.4 plus 0 1 plus 0, this would give me 0.4. Okay, now let's solve. Next question. The Gaussian curvature of a cylindrical cell having cycloidal directrix is uh, so we know Gaussian curvature is found by multiplying principal curvatures and times 1 by r2, and we know that r1 is equal to infinity, that is k1 equal to 0. So this gives k equal to 0. So correct option is option B, 0. So next question. Which of the following cell is anticlastic? So anticlastic cells are those for which the center of curvature is on opposite side of the cells, and we know for hyperboloid this applies. So correct answer is D. Now next question. We are given with a square membrane of size 2a by 2a which is subjected to uniform pressure Q. The tension in the stretched membrane is constant and assumed as 3. The edges of the membrane is supported. The maximum deflection in the membrane is given by. So as you have all seen in module 8 lecture 1, in the last part we'll see you have seen that displacement is given by z is equal to pn. You have seen that displacement is given by the relation z is summation n equal to 135 bn cos pi x by 2a times yn, correct? And so let us take only the first term, that is p1 cos pi x by 2a y1, and this y1 is given by the relation b cos hyperbolic of pi by 2a y plus particular integral yp, and yp is given by the relation 16 qa square upon pi cube b1t. Okay, so then applying the boundary condition. Okay, so if we substitute this, we have y1 is equal to b cos hyperbolic pi by 2ay plus 16 qa square upon pi cube b1t. Applying boundary conditions, y is equal to applying boundary condition at y equal to plus minus a, y1 equal to 0. So this will give me 0 equal to b cos hyperbolic of pi by 2 plus y is 16q a square upon pi a pi q b1 t. So this is maybe is equal to 16q a square pi q b1 t times this is minus cos hyperbolic of pi by 2. Thus our y1 is will be given by the relation 16q a square pi q b1 t 1 minus cos hyperbolic of pi by 2 y upon cos hyperbolic of pi by 2 implies our deflection would be using the relation this will get 16q a square upon pi cube t. This would be equal to cos hyperbolic of pi by 2 ax 1 minus cos hyperbolic of pi by 2 ay by cos hyperbolic of pi by 2. Okay, so z max would be it will be max at 0, 0 and that will be equal to 16q a square pi cube t. This would be equal to 1 and this is equal to 0.3104 q a square by t. So correct answer would be option A. Okay, now let's move on to the next question. The further questions are relevant to the assignment 9. So let's do this. So ninth question is write true or false against the statement made about the geometry of surface of revolution. Statement is in a surface of revolution of cell R1 is the first principal radius of curvature at a point on the middle surface. The second principal radius of curvature R2 is given by the distance between the point on the cell mid surface and the point of intersection of the normal to the cell mid surface at that point with the axis of rotation. So yeah, this statement is true. Okay, 10th question is in a cell of surface of revolution R1 R2 are two principal radii of curvature. If Q is the intensity of the load normal to the surface, then the relation between n theta and n phi will be. So we know the relation n phi upon R1 plus n theta upon R2 is equal to WR, and here in this case WR is equal to Q. So we can simplify n phi upon R1 plus n theta upon R2 equals to Q, which will make R2 is equal to Q minus n phi on R1, and multiplying with R2 on both sides will get Q upon R2 and phi R2 upon R1. This is my relation. Now let's match, and it matches with option B. Okay, Now next question. Next question is the roof of a large hall, circular in plan, radius 10 meter, is designed as a RCC spherical dome of thickness 90 mm. Live load may be considered as 0.15 kN per meter square. The central rise of the cell is 4 meter. Using membrane theory with the above data, it is found that as it is an axis symmetric problem, we know n theta phi would be equal to 0, and if we find the angle, okay, so also let's draw the figure. It will be so it is R F. So let's draw the diagram. So we are given with a spherical dome whose rise is 4 meter. There is a roof of large circular in plan. So this means the plan is in circular and the radius is 10 meter. So we are given with this radius as 10 meter. If you want to calculate the radius of curvature, so so using Pythagoras theorem, r square is equal to r minus 4 whole square plus 10 square, and okay, so this will give me okay, so this will r square plus 16 minus 2 4 100. So this gives me r is equal to 116.8. So that is equal to 128. So this is equal to 116, 14.5. Okay, and okay, and alpha alpha is equal to tan inverse 10 upon 10.5. Which is less than 45 degree, and which in turn is less than 51.8 degree. So this gives that my n phi at all levels n phi and n theta would be compressive in nature. The correct option is option A. Okay, moving on to the next question. Consider a spherical dome for which R1 equal to R2 equal to 10 meter. It is subjected to snow load of intensity 1 kN per meter square. The membrane strain stresses at the crown of the cell. So we know at the crown of the cell, n phi and n theta is equal to PR by 2, which is equal to 1 into 10 by 2, that is 5 kilonewton per meter square, and both are compressive. So correct option is option D. Now let's move on to the last section of the question. Okay, so we are given with an RC spherical dome which has the following data: thickness is 75 mm, live load is 3.5 kilonewton per meter square, span of the dome is 12 meter, rise 2 meter. The dome is supported by the ring beam. According to Membrane theory, so the magnitude of medial stress in Newton per mm at the ring level we need to find. So we have so we are given with this. Let's name them this. This is R. We are given with 2. This is 6, and this is R minus 2. So using Pythagoras theorem, R square is equal to R minus 2 whole square plus 6 square. This would be equal to 4 minus 4R plus 36. This gives me R is equal to 40 upon 4 equal to 10 meter. Okay, so now we're given with the thickness at 75 mm, live load as 3.5 kilonewton per meter square. Given with the live load as 3.5 kilonewton per meter square, which is equal to, so this is this now. Okay, so according to, let's take it to the next page. According to membrane theory, n phi is equal to minus WGR upon 1 plus cos phi and we have 10 phi. Okay, so we have cos phi as R minus 2 upon R, that is R is equal to 10 minus 2 by 10. So this is 0.8. So finally WG is 3.5 times R is 10, and this will be 1.8 minus 2.55 by 1.8. So this is equal to minus 19.44 kilonewton per meter square. Okay, now my diurnal stress would be equal to N uh, minus 19.44 into 1000 upon 1000 into thickness is 75. Okay, so this is okay. This is minus 91 kilonewton per meter, converting it to mm, and we have this. So finally we have 19.44 divided by 75. So this is equal to minus 25.88 into 10 power minus 2 Newton per mm square. This is equal to minus 0.26 Newton per mm square. So answer is 0.26. Okay. So we were asked with the magnitude and answer is 0.26. Now let's move on to the last question. So we need to find the tensile force in the ring beam. So tensile force in the ring beam would be tensile force in the ring beam would be n5 times cos phi times r sin phi. So n5 is 19.44, cos phi is 0.8, and r sin phi is 6. So this is equal to 93.33 kilonewton. Okay, so that's all for today. If you guys have any doubts, please utilize the discussion forum. If I get chance, I will try to answer your doubts. Okay, that's all for today. Thank you all. Have a nice day.